from whatever source we could. Back then, there were hardly any scallops around here, so we actually had to get them from places up in Massachusetts and Maine, wherever we could get them. And the idea was to bring them down here, plant them out in the bay, and then hope that they would survive and then reproduce and then bring the populations back. So because we had brown tide for the first few years in a row, nothing happened. We didn't get any benefit from that. But later in the late 90s and the late 80s and early 90s, the populations actually did start to come back. So the project was working. We had a scientist who worked with us who looked at the genetics of the scallops, and she determined that about 25% of the scallops that appeared in 1990 actually were derived from the planet. So we knew it was working, everything was going good. We had another brown tide in 1991, not too bad. And then all of a sudden, because the populations were building up, 1994 we had a tremendous year. Yes, question?
Can you explain to me what exactly a brown tide is?
Well, brown tide, that's a good question. Brown tide, it's a bloom of single-celled algae, and they're really, really tiny. I mean, the diameter of a brown tide cell is about 2 microns. Okay, so very, very small. But what brown tide does is it interferes with the ability of scallops to feed. Okay, now scallops are filter feeders. You guys know what filter feeders are? Okay. So clams and oysters and scallops are all filter feeders. Okay. Normally they will feed on phytoplankton, the single-celled algae that are larger, like 5 microns, 7 microns or larger. Right? So they like the bigger stuff. But the real small stuff they can't handle very well. Okay. Now it's not just about the size. It turns out that on the surface of the cells of the brown tide algae, there's some toxin that interferes with the scallops being able to feed. In fact, what they do when they filter feed, if you guys know, they have all the cilia on their gills that beat in coordinated fashion, and they create water currents that come through. So this toxin actually affects the ability of the cilia to work. And when the brown tide's present in high enough concentration, they stop pumping. All right? So they literally will starve to death. And we've seen this where we've monitored scallops over several months. They will just wither away, and then they'll die. And that's exactly what happened during the brown tides when they last.
What caused the brown tide?
That's a very good question. We don't know where it came from. No one still has an answer to that question. Brown tide appears to be able to outcompete other types of algae. It actually can use organic nitrogen, whereas most plants use inorganic nitrogen. So they have some kind of competitive advantage.
They breed quickly too then.
Yeah, oh yeah. When these cells reproduce, the densities were 1 million cells per milliliter. Okay, and the water looked like coffee. And when we dove in it, you could see about this far in front of your face. And that was it. You're just kind of feeling around.
So can you predict when a brown tide?
Not yet, but scientists have been working on this. They have some better ideas about what might prompt a brown tide. There's been some suggestions that if you have a long dry period and then all of a sudden you have a big rainstorm, that they think what happens is that water comes from the groundwater and comes up from the bottom of the bays and introduces nutrients that way. So no one's really sure, but we're fortunate in this area of Long Island, the Peconic Bays, that we haven't had brown tide since 1995. So, does that answer your question, Brian? Yeah. No, so that's a good question. That's what brown tide did. But so in 1994, the populations built back up to where we thought, we've gotten through it all. We were back to the good old days, and the harvest that year was, like it was prior to the brown tides. So we thought we were done with our restoration work, we made it, everything's great, but in 1995 we had a massive brown tide and it wiped everything out again. So we had to basically start over again after that. And so we worked on a lot of different things, and then, we didn't know if brown tide was going to come back. We still don't know if it's going to come back. I always say this, I'm not going to, and I do this religiously, that, we hope it's not going to come back. But so there was this window of opportunity in about 2003, we applied for a grant through Suffolk County and to go after bay scallop restoration. And we decided to go after it in a much bigger way than we'd ever done before. So we've gotten over $2 million for this project. And so the basic idea is the same as we did in the late 80s, was to get scallops and then plant them out in large numbers and hope that once they reproduce, the populations will come back. And our theory, though, this time was that what we wanted to do was not just plant scallops, but plant them so that they're really close together. And our hypothesis was that the reason scallop populations didn't recover on their own after 1995 is that the numbers and the density were too low. Now, when scallops reproduce, they release eggs and sperm into the water column, and the eggs get fertilized. Okay? There's been a lot of research that's been done with other species that's shown that if the males and the females are too far apart, the eggs never get fertilized. And the research suggests that if they're further apart than about a half a meter, they're not going to fertilize. So we were seeing densities of scallops in natural populations of 1 per every 10 square meters. All right? So if you have one over there, and you have one over there, and you have one over there, the eggs probably aren't going to get fertilized. So our idea was to put them all really close together so that when they got fertilized, or when they release the eggs and sperm, that the eggs will get fertilized.